Rocafort from BSS 3G. We are here to discuss graphics pipeline. What is the graphics pipeline? Graphics pipeline is a conceptual model that explains how a 3D scene is transformed from a set of vertices to a 2D image. In other words, graphics pipeline which explains the process of converting a 3D scene into a 2D image that can be viewed on a screen. It has a various stage, each of which is in charge of a different part of his change. We have two processing in graphics pipeline. The first one is vertex processing. The graphics pipeline starts by processing the vertex data of a 3D model, going through various transformation stages. In the graphics rendering pipeline, vertex processing is a crucial step that converts the 3D coordinates of vertices in a 3D model into 2D coordinates on the screen. There are numerous crucial steps in this process. The next one is fragment processing. The final stage is the rasterization and fragment processing, which takes the output of the vertex processing stage and produces a final image. Fragment processing, also known as pixel processing, is a critical stage in the graphics rendering pipeline, occurring after vertex processing. Its primary purpose is to determine the final color and attributes of individual pixels on the screen.
Nato from BSCS 3D. Stages of the graphics pipeline. The first stage is modeling, where artists and designers create the 3D assets and their various attributes. The first step in the pipeline for producing 3D graphics is modeling, during which designers and artists generate three-dimensional elements and specify their many properties. In this procedure, 3D people or objects are created to be used in computer-generated settings like video games, simulations, movies, or architectural visualization. The vertex processing stage is where 3D data is transformed and prepared for rendering. Vertex processing is the stage graphics pipeline where 3D model vertices undergo transformations. Custom calculations are specified by a vertex shader and are prepared for further processing to eventually create the 2D image that users see on their screens.
Renz Fabunan from BSS 3D. Rasterization and fragment process. In rasterization, merge the 3 triangles into pixels to create a 2D image. In this task, an image described in a vectorographics format and converting into a raster image. Fragment processing handles the lighting and the shading of the individual fragments or pixels, as well as complicated effects like transparency. In this procedure, the fragment shader is the core component responsible for processing individual fragments, applying various calculations and texture to determine their final appearance on the screen. Frame buffer operations applies any final operations to the rendered image like post-processing, effects, or blending with other layers. In this task, frame buffer operation efficiently for complex tasks like rendering 3D scenes, applying textures, and handling users' interface elements. Conclusion and key takeaways. Performance matters. Rendering a 3D scenes with high quality and performance requires a lot of optimization and fine tuning. Improving the pipeline. The graphics pipeline is always being improved upon as developers and designers push the envelope with what they can do with real-time 3D graphics.